Hello, everybody. Thank you for coming to our talk today. Our talk today is towards a more perfect pipeline, and we are USAA, also known as the United States Automobile Association. So today's speakers are myself, Michael Sturm, my testing expert, Timothy Shiveley, and my automation expert, Aaiden Witten. So we are USAA, and we are a financial services company focused on serving the military members and their families. USAA was founded in 1922 by a group of 25 Army officers who were deemed too high risk to get auto insurance. And the reason for that was Army officers would travel around a lot, and they would be driving long distances. And so it's 1922. Auto insurance underwriting isn't very mature, and a lot of companies just said, you drive too much, we're not insuring you. So these Army officers decided to found USAA in San Antonio, where we're still headquartered today. We have grown from 25 members to 13.5 million customers. We do $48.6 billion in revenue annually, and we currently have 37,000 employees, and we hold 3,000 active and pending patents. So I mentioned earlier, USAA is a financial services company, and we're comprised of two pillars. We have an insurance company, USAA P&C, which is the 7th largest insurer in the US, handling $31 billion in premiums annually, and we have USAA Bank, which is the 20th largest bank in the US, with $220 billion assets under management. So what do we do for USAA? What does our team do? We build marketing data warehouses for USAA with DBT. We handle 50 plus data feeds. We have 7,500 database tables in our data warehouse. That comprised of 43 terabytes of data, feeding 10 plus Tableau dashboards, and we manage 15 plus marketing vendor integrations. And our ultimate goal at USAA is to make sure that our ad spend is effective and we continue to grow the company. And you'll commonly see us sponsoring events such as the Army-Navy college football game and the Super Bowl. So for today's talk, we're going to talk about how we improved our release pipeline to build trust in our data pipelines via testing and CI/CD pipeline jobs. So the presentation is called, today's presentation is about building trust, and our presentation title was inspired by the U.S.'s Constitution's phrase of a more perfect union. So where did that phrase come from? Why are we talking about this at a data conference? It came from a joke from a code review. We had a SQL union we were reviewing, and someone posted, use DBT utils union relation to form a more perfect union. I thought it was a pretty funny comment. I liked it a lot. So it got me thinking, what does a more perfect union mean? Why is that in the Constitution? And it basically means embrace continual improvement, acknowledging that perfection is unattainable, but relentless progress is essential. So, as I mentioned, today's talk is going to be about how we improved our release pipeline to build trust in our data pipelines. When we first started using DBT, we had gone from an on-premise ETL solution to the cloud with an ETL paradigm. We were using DataStage and Netezza on-premise, and we went to DBT and Snowflake. And so we had a lift and shift culture when we started. We used automated conversions of all our ETL flows to put them in DBT, and that led to a lot of minimal DBT features being used, but the expectation stayed the same. Our data needed to be correct, we needed to make no mistakes, and we needed to catch the issues early. So how do we preserve quality of the legacy system while getting the benefits of the cloud? This was our release pipeline when we first started. And you can see here, the first time we ran a lot of our models was in production. And because of that, that'd be the first time we saw compilation errors, runtime errors, data errors, and logic errors. We had great tests, but what good are tests if they're running in production? They're failing. Your data marts are broken, all your reports are broken. We needed to start testing and validating earlier, and we had to start shifting our testing left. So as we go throughout this presentation, you'll see this image again updated with how we shifted our testing left. So if we were going to shift left, we needed environments to shift left to. And we used Snowflake to invest in different warehouses with different purposes, different warehouse environments. So the first one we built was a rapid development where we had full developer CRUD access. And the purpose of that was prototypes, proof of concepts, and developer schemas that they could run locally. We created development and test environments for validation and testing, and we created a production QA environment where we could run our jobs in a production environment on production data, but not in the actual production environment that our reporting and analytics were running off of. The other issue we ran into was we didn't have a lot of trust in DBT when we first started using it. As I mentioned earlier, we used an automated conversion of data stage to DBT, and that left us without comments, without DBT tests, and no descriptions, and we had a lot of abbreviated naming standards. And we noticed developers were very scared to make changes because they didn't know what any of the code was. And it led to a lot of performance issues going from an ETL architecture to an ELT architecture. And as you can see at the bottom, a lot of our project summaries in DBT Explorer looked like this. 0 test coverage, 0 model documentation, not very good. So we decided to embrace DBT, lean into it, and make it a best practice to start filling things out. We added built-in generic tests and filled out our descriptions. We updated our legacy naming standards, and we added a lot of code comments. And the results were errors became more obvious, duplicated code became more obvious. We understood what our data was, who was using it, and what the models were building. And a big bonus, our AI code assistants worked a lot better. And you can see we went from 0 to 99% test coverage and 100% model documentation. So that was kind of the foundation we put in place to start building trust in our release pipeline. And I'm going to turn it over to Aaiden, who's going to talk about advanced testing he built on top of that pipeline.
Hey, thank you, Michael. Hello, everyone. In this section, I'm going to cover how we built custom tests in DBT to further shift error detection to the left to safeguard that trust that Michael just spoke to. What you're about to see is how we built and configured our production staging environment to enable performance testing, and how we were able to implement task-driven development in our DBT code. So let's start with the problem of performance testing. We had a DBT lineage that was completely built out of ephemeral models. This meant that at runtime, the entire lineage was compiled and ran as one long SQL query. And this design worked really well for a while, but as data volume increased, so did the runtime, until eventually it breached our 1-hour query time limit in Snowflake, causing our job to fail. So this lineage needed a performance enhancement, but we had no way to simulate the scale of production's data volume to test our changes without deploying and testing directly in production, which Michael just spoke to as a flaw in our release pipeline. So our solution to this was to build a standalone staging environment that writes to its own isolated database using its own isolated warehouse, but shares source data with production. By sharing source data with production, we were now able to validate all of our changes with production data and production's data volume before deploying to production. And this enabled for us the true potential for performance testing. So back to the ephemeral problem that we had, how did we fix it? The first thing we did is we swapped all the ephemeral models to be tables. And now our job could at least pass that 1-hour time limit in Snowflake. But this wasn't actually a performance enhancement, and now it's taking our job a full 75 minutes to run. And this is far too long. So using the production staging environment, we experimented with other warehouse sizes and found that on an extra large, the same job took just 15 minutes. Now, that's not only that's not only faster, it was also cheaper because it consumed less Snowflake credits. So this insight inspired us to create a reusable performance test where we could take any DBT job and run it across each warehouse size to determine which warehouse was both the fastest and the cheapest. So we did that for the ephemeral problem, and we plotted those points for you all to see here. The purple line here represents runtime, and the orange line represents cost. We needed to find the lowest point at which these two lines intersected in order to determine what was the most appropriate warehouse size for this particular job, which you can see is right here, just past the extra large warehouse, which is how we determined that was the best warehouse for this job. But now we had a reusable performance test that we could use to right-size every DBT job across our entire domain. Here is the release pipeline that Michael showed earlier, showing you that not only did the implementation of this staging production environment that sources from production data, not only did it enable performance testing, but it also shifted all of our error detection to the left, allowing us to catch errors faster and, most importantly, not in production, right? This further safeguarded our data pipelines in production and thus safeguarded our trust. Now I'm going to move on to how we used DBT to enable test-driven development. I love test-driven development. My background is actually in software engineering, where I used it a lot. It promotes more proactive and effective testing. It allows developers to catch errors and bugs faster, and most importantly, it leaves a trail of regression tests in its path. So I'm always eager to see how test-driven development fits in the data space. So I'm going to show you 2 example tests that we wrote following test-driven development principles, 1 unit test and 1 integration test. So we had an impossible scenario in our production data where a user was reported having interacted with an ad without ever having clicked on that ad. We called this problem the phantom click problem. As you see here in this top box, this user has 0 impression quantity, which means they were never served this ad, but they have 1 click quantity, which means that they clicked on it. This is impossible, but it was still happening, and we needed to ensure that our models were handling these records appropriately. So how did we use test-driven development to solve this problem? We used DBT unit tests. DBT offers a unit testing framework that allows developers to input mock data to their models and assert its output, ensuring that that model is handling these edge cases appropriately. So here's how we used unit testing to solve the phantom click problem. Up on the screen here, this is an example of a unit test right here that you would see. You define it in your configuration file like this. Use the unit test keyword to indicate that you're defining unit test. Here's where we passed our model under name. And then under the given and given's row field, this is where you define your input mock data. So for us, we would go get the phantom click edge case, and this is where we would define that. And then you would assert its output here under expect, ensuring that that model is handling that edge case appropriately. Now, we found that defining mock data this way created a lot of bloat in our YAML files. You know, we were creating dozens of unit tests, and defining all of your mock data here can get really bloated. So instead, we used CSV fixtures, right? So DBT also allows developers to import CSV files as fixtures directly into your project and to be passed into your unit tests as your mock input data and your data for asserted output, right? So what we did for the phantom click is we went to Snowflake, queried our edge case directly in our production, downloaded that data as a CSV, imported it in the project, and passed it directly into the unit test. By doing this, we were able to cut down time, or by following this process, we're able to cut down time on creating these mock tests ourselves, mock test data ourselves, and we ensure that the mock data perfectly captures the edge case we're trying to test. So again, back to test-driven development, when would you write this unit test? It's important when you're following test-driven development principles that you write the test before you start the development. So this would all be before writing logic in your models. Once your unit test is written, then go add that logic to your models and then to pass the test. Right? Now you've not only ensured that your model is handling these records appropriately, you've now created a long-term regression test to protect this edge case forever in your code base. So this is one example of how we used unit testing to enable test-driven development using DBT. Now I'm going to wrap up my section with an integration test that proved to be particularly useful for us. We had a problem where records were being unintentionally dropped from our final data marts. This was typically the case because of errors on join conditions, errors in our where clauses, and most notably in our incremental models logic. the incremental strategies. So to solve this problem using test-driven development, we created an integration test in the form of a DBT singular test that aggregated key metrics from the source and those same key metrics from the target and compared them. It's very simple and straightforward. If those two values did not equal, that indicates that there was a data loss. But now we know about it ahead of time, and we could respond proactively. We took this DBT singular test a step further and scaled it up with a generic test, making it reusable and seamlessly adoptable across our entire DBT lineage, all of the lineages in our entire data domain. We implement these integration tests at the early stages of our DBT builds to ensure we're following best practices for test-driven development and that we're catching bugs and errors as soon as possible. But it's also not just a one-time check. We also run this job every day with our ETL incremental jobs to ensure that at the end of or at the start of every day, our data is consistently accurate in our entire domain. So here is the release pipeline again to show you that with the implementation of test-driven development via DBT unit tests and this integration test, we were able to further shift our logic and data errors to the left, and we're finding them as early as in local development. So now I'm going to hand it off to my colleague Tim, who's going to talk about how he built automations on top of this testing.
Thank you, Aaiden. All right, in this section, I'm going to cover how we utilize DBT's CI/CD jobs to ensure and enforce the automated execution of the tests that Aaiden just spoke about. So we were a pretty large team with a large scope of work, and because of that, we were committing a lot of merge requests to our repository every single day. We wanted to ensure the quality of every merge before it got added to our main branch. But with the pressure to deliver our code to production environments as soon as possible, our review process quickly became a bottleneck. And a culture of let's get this merged or looks good to me became normal. This diagram shows what our merge request review process looked like at the beginning of our testing automation journey. Whenever we opened a merge request against our repository, in order to thoroughly validate it, we had to pull that branch down, then build it and test it locally before going back and giving our confident approval. Now, this wasn't required. So what good are these tests if they're not being run, right? I was complaining about this to a coworker because it frustrated me that all of this testing was optional and bad code was making it into our main branch, meaning we'd have to go back and fix it, go through another merge request review. It was repetitive work. This coworker told me a little bit about CI/CD jobs in DBT, which allow you to execute your code from the merge request and validate it right there in line. I was really excited because this sounded like the perfect solution to this optional testing problem that we were having. I quickly developed a proof of concept using the DBT CI/CD jobs, and this is what our process looked like after that implementation. Now, whenever we opened a merge request against our repository, GitLab would let DBT know that a merge request had been opened, and DBT would run the command that we had configured inside of our CI/CD job. This command was a full build for us right here at the beginning in the proof of concept. And so it would run our entire project, and this would ensure that we had no compilation errors, no runtime errors, and it would run all of our custom tests, ensuring that we had no logic errors or data errors. If the merge passed all of these validations, DBT would let GitLab know, and we'd be able to approve with confidence and merge the code into our main branch. But if it failed any of those validations, DBT would let GitLab know same way, but now it's a failure and the merge is blocked and it cannot be added into our main branch until the developer goes back and rectifies whatever is wrong, submits another commit, another CI/CD runs, and it has to pass. And this was really easy to configure. You only have to select a few toggles. You have to give it a command to run. Here on our first pass, it was dbt build. Run everything, test everything, make sure that it is successful. We quickly ran into a problem. Our dev builds became very slow. We had a lot of models. We had a lot of tests on those models. In our dev environment, we were running on an extra small warehouse because we had cost considerations. But extra smalls run slow, so all of our CI/CD jobs were time consuming. Here is an example where it was 20 minutes before you got any feedback of whether it was successful or failure. And based on all those commits right there, you can see that it took a few passes before we got one through. So we wanted to solve this. And we knew that dbt deferral could allow us to reduce what we were running inside of the CI/CD stage. dbt deferral allows you to have a pre-built version of your project and then reference that pre-built version to only run a narrower subset of your models. In our case, we were only running what had been changed and what has come after the change to ensure that the modified model does not affect anything downstream. And this was also pretty easy to set up inside of dbt. All you have to do is give it which environment you're deferring to, and then update the build command. In our case, we're using dbt build select state modified plus. Plus gets you everything downstream. We ran into another problem. Our builds weren't any faster. Deferral is supposed to take care of this for us, right? So what we found was inside of our post hooks, we had code that was being evaluated at compilation time. This was changing the definition of the model every time that CI/CD job ran, marking it as modified. And these were pretty early on in our DAG. So it was running a lot of our models still. We solved this by going to a static compilation through the use of a pre-configured macro where all we had to do was send variables to it. The variables don't change on any given model. So now whenever it compiles, the definition of the model doesn't change and the models don't get marked as modified. You can see from the two timestamps at the bottom that we went from a 30-minute execution without the static compilation to an 8-minute execution with it. We were finally at a point where our CI/CD process was feeling good. It was snappy. We were getting feedback quickly. It was running all of our tests, so we were assured of the quality of the code inside of each of our commits. And so now, whenever we opened a merge request, GitLab still sends the same information to dbt. dbt runs that slimmer CI, and we get the feedback from dbt much faster. We have the same assurance of quality, and this frees us up to focus on the business logic of the change and the architecture of the change, getting our plane of understanding a level higher. Now we're back to our release pipeline one more time, and we can see that now with the CI/CD jobs, we have enforced the automatic execution of all of our tests, ensuring that we catch all of our logic errors, runtime errors, compilation errors, and data errors at the merge step before anything makes it into our main branch or goes out to either of our production environments. Now I'm going to pass it back to Mike to talk about all the value that we got out of this process.
Thank you, Tim, for that awesome overview of CI/CD jobs. They have been a game changer for us, and they make code reviews fun. It's nice having dbt and GitLab automatically build the code for us and let us know right then and there, this change works or this change does not. So what's the point of all this, right? We added all these environments, we added all these tests, we added all these optimizations and automations. What did we see? And again, some numbers for y'all. We saw a 95% reduction of build failures in our production environment. By running the CI/CD jobs, by building locally, we would catch them all earlier. And as Aaiden demonstrated earlier with our performance optimizations, we saw a 20% reduction in our cloud infrastructure spend. We were able to right-size our warehouses to the queries. By embracing dbt, we achieved 100% test coverage and project documentation. Okay. I guess the wall's real excited about that one. So we saw a 90% reduction of code review time, right? We didn't have to pull down changes locally on our machine, build them, run them, set up the schema, set up the databases. It just all ran. And by shifting that developer feedback cycle left, we were able to see a 25% reduction of our feature development time, which was pretty huge. So to kind of recap, right, a more perfect pipeline, USA is known for our excellence, and we really wanted our work to reflect that. We really wanted to embrace continuous improvement with our data pipelines, acknowledging that, again, perfection is unattainable, but relentless progress is essential. And on that note, what are we looking forward to? What is our next relentless progress? We want to scale, monitor, and evolve. So we want to scale these culture and best practices out to more projects at USA, and we want to start adding testing to the right. And testing to the right would be monitoring our production runs, checking for anything that could be degradation of performance over time, or searching for anomalies in our data. And then, obviously, we want to evolve into the future with AI/ML, and by setting things up like more AI-driven agentic programming using dbt's MCP server, and it's not on the slide deck, but after yesterday's great keynote, we want to add dbt fusion as well to our workflow. So thank y'all for attending our session. I hope you're inspired to go perfect your pipelines and start improving them. And we've gone a little bit long, so we'll be downstage if you have any questions that you want to ask us. Thank you so much.